In this video, we are going to explore the ln command in Linux. We'll learn how to create both hard and symbolic links, understand their differences, and see practical examples of how they can be used. Let's begin by understanding what links are in the context of Linux. There are two main types of links: hard links and symbolic links. Hard links are a direct reference to the inode of a file. It's important to note that hard links cannot link to directories or span across file systems. All hard links have equal status, and the file is only deleted when all hard links are removed. On the other hand, symbolic links are special files that point to another file. They can link to directories and can span across file systems. Breaking the original file will break the link. Symbolic links are similar to shortcuts in Windows. Now let's explore the basic syntax of the ln command. The general structure is ln, followed by any desired options, the target file, and the name you want to give to the link. To create a hard link, the command is simply ln source_file link_name. To create a symbolic link, you use the s option, like this, ln s_source_file link_name. Here are some common options used with the ln command. S or symbolic creates a symbolic link instead of a hard link. F or force removes existing destination files. V or verbose prints the name of each linked file. I or interactive prompts whether to remove destinations. Let's see an example of creating hard links. First, create a file named original.txt with the content hello world using the echo command. Then create a hard link to this file named hardlink.txt using the command ln original.txt hardlink.txt. When listing the files with a ls_li, both original.txt and hardlink.txt will have the same inode number. Here are some key points about hard links. Both files share the same inode number. The link count is 2 for both files. Modifying either file updates both. Deleting one file doesn't affect the other. The file is only deleted when all hard links are removed. Here's how to create symbolic links. First, create a file named original.txt with the content hello world. Next, create a symbolic link to this file named symlink.txt using the command lnsoriginal.txt symlink.txt. When listing the files with a ls_li, original.txt and symlink.txt will have different inode numbers. The symlink.txt will have a special L file type, indicating it is a symbolic link. The output will show symlink.txt pointing to original.txt. Key points about symbolic links. Files have different inode numbers. The symbolic link has a special L file type. The symbolic link shows points to target in the ls output. Deleting the original file breaks the symbolic link. Symbolic links can point to directories and can span across file systems. When creating symbolic links, you can use either relative or absolute paths. An absolute path starts from the root directory, like /home/user/docs/file.txt. A relative path is relative to the current directory, such as /docs/file.txt. Using an absolute path works from any directory, but it breaks if the target file moves. Using a relative path works if the link and target move together, but it breaks if the link moves alone. Here are some best practices. Use absolute paths for system files and permanent links. Use relative paths for project files that might move together. Always verify symbolic links after moving directories. You can use the readlink command to see where a symbolic link points. Let's explore some common use cases for links. One use case is version management. You can create symbolic links to the current version of software. For example, lnsf python 3.9/usr/bin/python. Another use case is shared resources. You can link to shared files across user directories. For example, lns/shared/data/data. Links are also useful for backup strategies. Use hard links for efficient incremental backups. For example, CPL backup point 1 backup point 0. Finally, you can create command shortcuts. Create shortcuts to frequently used commands. For example, lns/usr/bin/python3/bin/py. Let's summarize the key differences between hard and symbolic links and review some best practices. Hard links are a direct reference to the inode and share the same inode number as the original file. They cannot link to directories or span across file systems. The file exists until all links are deleted. Symbolic links, on the other hand, are pointers to the file path and have a different inode number from the original file. They can link to directories and span across file systems, but they break if the original file is deleted. Here are some best practices. Use LNS for most everyday use cases. Use LN for hard links when implementing backup strategies. Use F to overwrite existing links. Check links with ls, l, or read link. Be careful with relative paths in symbolic links. Use find type else type L to find broken symbolic links. Consider using V for verbose output. Document your link structure for system maintenance. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.